Okay, one more time because we just discussed this. So these are the options for the final exam. Beyond Wednesday, the final exam grade is 0. So you must choose one of these options. Monday from 5 to 7, Tuesday from 3 to 7, and Wednesday from 3 to 7. And as I just mentioned, if somebody wakes up on Thursday saying, oops, I missed the 141 exam, final exam, I already turned in the grades with a 0 for the final. So please make sure you show up. Please. All of them in this room. There may be a conflict here between 3 and 5, but I will make it work.
Can you still replace the amount of test grades with the...
Yes, yes. If your final exam grade is 90% and your lowest test grade is 50%, I'll replace the 50% by 90%. But everything, I mean, the final exam stays as the final exam. Okay, very good. So I would like us to choose something from 18 and something from, and yeah, solve the missing, yeah, we have 3 options for 19. Which one would you like to choose? Don't leave, I want to get your email address. Okay. And they made up their minds, it's April the 22nd. It's not the 15th, or 16th as I thought. It's the 22nd. Okay, so which one? A, B, C, D, E. We want to do A? Is that what you said? E. This one. Okay, very good. So we have secant theta equals 3x minus 2 divided by 5. So we're asked to find the other 5 trigonometric ratios of theta. 5 trigonometric functions. Okay, very good. So here's a right triangle with an acute angle theta. What do I know about secant? Secant is a sophisticated trig function, but it depends on sine or cosine, or both. 1 over cosine theta. So now I will flip both sides of this proportion. I will flip both sides. So then I get that cosine theta equals 5 divided by 3x minus 2. What do I know about cosine theta? What is the ratio? What does it mean? This over that. What is this and what is that? What is cosine? What does cosine equal to? Very good. Adjacent over the hypotenuse. 5 is the top, which is the adjacent. 3x minus 2 is the bottom, which is the hypotenuse. So I have to find this. I'm going to call it y. Once I find the other leg, then I can determine the rest. Okay, you can say, but I still can determine the rest without finding the opposite leg. True. Assuming I don't want to find, we will in a minute, but assuming that we don't want to find the other leg, how will I determine if I have cosine? How will I determine sine? In any other way except, although we are told to use the triangle. We're going to use the triangle. But assuming I don't want to use the triangle, how will I find sine theta? So sine theta equals plus or minus the 1 minus squared. So that's another way. Good. Okay, so let's stick with what they are asking us to do. So let's find y. How do I find this leg? There is a theorem that I can apply in a right triangle and only in a right triangle. Good. So please dictate. How do I write the Pythagorean theorem in this triangle? Very good. The hypotenuse squared equals the sum of the squares of the 2 legs. Yes, or 25 plus y squared. All I have to do is move everything to one side and get y by itself. So when I square this, how many terms do I get? And remember, we made a contract 3.5 months ago. How many terms does that have? Not 2 and not 4, but exactly 3. I'm ready. Yes. 2 times 2 is 4, 4 times 3 is 12, plus 4 minus 25 equals y squared. So this is 9x squared minus 12x minus 21 equals y squared. I take the square root. Since it's a distance, it's a leg, it's this. Oh, I'm hiding it. Sorry about that. Okay. So now I have, yes, please. Any questions? Oh, you said bless. Okay. So now I have cosine. Now I want to determine sine theta. Can anyone give us sine theta? Now I know that this piece is the square root of 9x squared minus 12x minus 21.
So it's
It should be plus or minus, but I can't put plus or minus. It's a distance. So that sine is, yes, that whole thing over the hypotenuse. So that whole thing, which is 9x squared minus 12x minus 21 over,
3x.
that's it. So once I have sine and cosine, it should only take me less than a minute to determine the other four. Would you agree with that?
Yes.
Okay. Good. So can anyone give us tangent theta? It's this, right, over this. But when I flip, since the denominator is both is the same thing, then when I flip, that will go away. So it will be the square root of 9x squared minus 12x minus 21 divided by 5. Because 3x minus 2 will get simplified with 3x minus 2. What about cotangent theta?
5 over
Right.
divided by square root of 9x
Good. What about secant and cosecant theta? And now just remember that I forgot to remind you, we have a session for review for the final exam on Friday from 3:30 till 5. I will be here from 3. I will not start per se because I promised 3:30 to 5, but I'll be here. If you have questions, please bring them to me at 3 o'clock. Okay, secant is 1 over 3x minus 2 over 5. We already have it, actually, right? 3x minus 2 over 5. And cosecant is 1 over this, which is 3x minus 2, everything over the square of 9x squared minus 12x minus 21. Very good. Any questions? Any questions? Any questions? Okay, so please choose something from 19 ABC. You have the answer should be in the back. It says answers right here somewhere. So you can do the rest. You can do A, B, C, D, and now let's choose one from A, B, C in 19. C, very good. So we are given C, which is, I'm sorry, B, which is 6, C, which is 1, and angle A, which is 146 degrees. I draw a triangle. I denote the vertices by A, B, C. I know the opposite of angle A is denoted always by little a, which I don't have. I know the opposite of B is always denoted by little b, which is 6. The opposite of C is denoted by little c, which is 1. And angle A is 146 degrees. Bless you.
Thank you.
So I know that I have basically two options. In some situations, law of cosine will not work, or may not. In other situations, law of sines may or may not work. So now this setup, when I don't have the opposite and I have the two sides and I have the angle in between, this setup is typical to cosine, law of cosines. Why? Because a squared equals b squared plus c squared minus 2bc times cosine 146. And I will determine a. So let's write the formula first, law of cosines. A squared equals b squared plus c squared minus 2bc. Remember cosine a.
Is that really given to some test?
If you don't remember, let me know. But this is the Pythagorean Theorem. If you just remember, the one side squared is the sum of the squares of the other two. But since this is not a right triangle, I have to subtract 2bc, 2 times b times c, times cosine a. Okay. So then please dictate. What should I write? So it's a squared is a squared, right? B squared will be 36. C squared will be 1 minus 2 times 6 times 1 is 12, and cosine 146 degrees. And of course, a will be the square root of all this. 37 minus 12 cosine 146. I have to put this in the graphing calculator. Make sure that the mode is in, of course. So make sure, yes it is. So I have the square root. Put everything in one step so you don't have to approximate anything. 37 minus 12 and cosine of 146. Close the parenthesis and close the parenthesis under square root. So I get 6.852. A is approximately 6.852, whatever the measurement unit is. Any questions? Any questions? Okay, now I would like to go back to section 5.1 on page 529. Let's say problem 58. Let's say 415, they want us to find a positive angle. Co-terminal with this one. Yes, please.
That's
Say it again. It's not on 58? It's not on 529?
Don't have.
Okay, that's fine. Thank you. You are too honest, and I have to reward you for that. Good. So I know that 415 is more than a complete circle, right? So when I subtract 360, I get 55 degrees. So then the angle starts here. I go 360, and then another 55. Right? So this is the angle. This is the initial side, and this is the terminal side. So I need to determine one co-terminal angle with 415. Co-terminal with 55. Is this the only angle? No. I can say 55 plus 2 complete rotations. I'm going to say 720. It's also 775. So 415 is coterminal with 775 as well as it's coterminal with 55. Because all these angles have the same, what is this called? Reference angle. Excellent. So this is RA, a reference angle. Very good. Perfect. I don't see anything else from section 5.1. Moving on to 5.2. We already looked at those one problem from 5.2. Let me just say, give me a co-function identity. Co-function with, let's say, problem 32. sine 19 degrees. Which is the co-function of sine? Cosine of 90 degrees minus 19. Therefore, sine 19 degrees is the same with cosine applied to very good. Okay, if I ask, let's say, the cofunction with, not cofunction, yes, cofunction, I'm sorry, of tangent 36. Tangent pi over 7. This is the same with cotangent of pi over 2 minus pi over 7. Have to find the least common denominator, which is good. What does this need? What does this need? And 2. How much is 7 pi minus 2 pi? So if you punch in the calculator, let's do that just for the sake of the argument. But the angles have to be, we shouldn't do this. I just want to show you how to verify. So what should the mode be in? Yes, make sure it's in radians because that's what we are going to punch in. Okay. So then now, tangent of pi divided by 7. Pi divided by 7. I do not have a key for cotangent, but I know cotangent is 1 over tangent. 1 divided by tangent of 5 pi over 14. 5 pi divided by 14. If these two are the same, which means I'm telling you tangent pi over 7 and cotangent 5 pi over 14 are the same, when I hit enter, what should I get? I have to get the same 0.48157461188. This is a way of checking that what I wrote is correct. Okay. Let's solve a right triangle or a problem. Let me look for, yes, 76 on 547. If it's a homework problem, lucky you. So 76. We have here 555 feet, and we have 1320 feet, and this is angle theta. And this is Washington Monument. It's 555 feet tall and standing 1/4 of a mile or 1,320 feet away from the base. We are looking up. Find the angle of elevation. What trigonometric function will I apply here? Indeed, what does it equal to? 555 over? Good. Now, how do I determine the angle? What should I do to both sides to eliminate this function? When we want to eliminate the function, we apply its inverse, right? So tangent inverse to both sides. So here's our tangent right here, tangent inverse right here in blue in the software. Inverse tangent 555 divided by 1320. Do not press enter. Go back to the mode and change it back to degrees first. And now you can press enter. So it appears that it's roughly 23 degrees.
So you picked a tangent because
I had the opposite and I had the adjacent.
Theta. So you
Yes, but I could have picked the cotangent, the adjacent over the opposite,
Okay.
or I could have wasted my time to find the hypotenuse, and then I could have used sine or cosine.
So you could okay.
Better?
Mhm.
Good. I can see anything else here in 5.2. Let's move on to 5.3. Let me also give you the formulas that I want you to remember. Okay? Here they are. And the numbers and anything that I would like you to memorize. Can anyone give us the first number right here? And the number here? And the number here? And the number here? And these two are the same. This is the only angle for which sine and cosine are the same. Very good. Okay, now around the unit circle. What are the coordinates of this point? Very good. Coordinates of this point. Very good. Coordinates of this point. Very good. And finally? Good. Now, which is the first coordinate? Is it sine or cosine? Excellent. Very good. So this and this and this and this are all cosines for those angles. So if I ask cosine 90 degrees, what will you say? If I ask cosine pi, what would you say? If I ask cosine 3 pi over 2 or 270 degrees, what will you say? And if I say cosine 360 degrees, you will say 1. Good. Now the second coordinate is always sine. So if I ask, what about sine of pi? 0. What about sine 3 pi over 2? What about sine of pi over 2? What about sine 0? Okay. Which two functions are bounded? Cannot go above and cannot go below. Only sine and cosine. And I will say they're bounded like this. So if I ask sine x and you say -3, how many points should you get? 0. There is no -3 of sine of any angle. Good. So cosine is also the same, -1 to 1. Now, what are the signs only of sine and cosine? Give me the signs of sine. In the first quadrant, sine is? Second quadrant. In the third quadrant. And in the last quadrant. Good. So these are signs for sine. Now I want the signs for cosine in brown.
Positive. Negative. Negative.
Good. So the signs in brown are for cosine. Now from here, I don't need to memorize tangent, cotangent, secant, cosecant, because if you say third quadrant, oh, tangent, third quadrant, oh, both are negative, so tangent is positive. Or if you say cotangent, the fourth quadrant, negative over positive. Oh, so they, yes, negative over positive, so it's negative. Okay? And these two, and I'm done. This is the only information I would like you to remember. Sine squared of theta plus cosine squared of theta is 1. From here, we have two more identities. Can anyone remind us which identities?
I thought it was 10.
Yes, 1 plus tangent squared or tangent squared plus 1, it doesn't matter, equals? Yes, secant squared. And the other one has cotangent here and cosecant here. Easy to memorize, I think. So 1 plus cotangent squared equals cosecant squared. Okay? However, I don't need to memorize these. Once I know that, I can always create the other two. Okay. So we're on 5.3. Let's look at 65 on page 560. Tangent 420 degrees. I have no idea what this is. I have to picture it first. Okay, so it starts here. 360 will be this. And how many more degrees I have to go further to get 420? 60 more. Remember? 3. So it's this. I need to find the reference angle. This is the reference angle. And then I will find tangent. So since this is 60 degrees, I can say that tangent 420 degrees equals tangent 60 degrees. And I'll say, oops, she told me not to memorize tangent 60. Not a problem, because I know that tangent 60 is sine 60 over cosine 60. And I know 60 is the last angle. What is its sine? And what is its cosine? And when I flip the top, I keep the top and I flip the denominator and I simplify, I know the answer. Okay, one more type of problem in 5.3 that I would like to go over is, let's say 26. It's okay if it's a homework problem, I don't mind. 26 cosine theta equals 4/5, and theta is in the fourth quadrant. So we're given cosine is 4/5. It's in the fourth. Theta is in the fourth quadrant, and I want to find the other 5 trig functions. Once I'm given cosine, which other function will do the deal? Will clear everything and solve everything? Sine. How do I find sine if I have cosine? That's the only way. So if I have cosine, I shouldn't say the only way. There are other ways. But that's one of the ways. But I have to think, what is the sign of sine in the fourth quadrant? Negative. So then sine theta equals negative the square root of 1 minus cosine squared theta. All I have to do, take 4/5, square it, put it in here, and find sine. How much is 4/5 squared? 16 over 25. So sine theta equals negative the square of 1 minus 16 over 25. How much is 25 over 25 minus 16 over 25? Yes, the square of 9 over 25. So then sine theta equals negative. Good. Now the rest is done. Once I have sine and cosine, and here they are, I'm going to write them here one more time. Sine theta equals negative 3/5, and cosine theta equals 4/5. Now, can anyone give us tangent, cotangent, secant, and cosecant? Okay, let's start with secant.
Negative 3/4 for
Yes, indeed. And for cotangent,
negative 4/5.
that's it. And for secant is 1 over cosine.
5 points.
Very good. And cosecant is 1 over sine.
Negative 5.
I can't think of anything else from section 5.3. Okay, let's look at graphs. Now let's stop if you have any questions for me. Okay, here's what I recommend we look at from 5.5 and 5.6. The only question I would like to review is, for example, 46. It's okay if it's a homework problem. Y equals 4 cosine 2x minus pi. I will ask you 3 things. One is the amplitude. 2 is the period, and 3 is the phase shift.
Are you gonna have us graph these? Okay, because I noticed that going over some of the problems last week, none of the graphing was done, you just.
No.
Okay.
No, no, for 2 reasons. Number one, I don't feel that I presented enough graphs for you to become very knowledgeable in graphing. We will graph them with a graphing calculator, and I don't want you just to copy a graph, right? We did a lot of exponentials and logs, although not a lot of graphs, but we did a lot of polynomials and rational functions. That, yes, I would like you to graph them, but these, no. I'm just happy with this. The amplitude, period, phase shift. Okay, can anyone give us the amplitude? And you have to write the absolute value of 4, and then you have to write 4. One more time, the amplitude is
Absolute value.
how high it goes and how low it goes. In other words, it can be imagined as the difference between the high and the low divided by 2. Okay, the period. I cannot determine the period. The phase shift. So the period can be determined now. So remember, cosine has a period in general, not this. Cosine x has period what? Yes, everything has 2 pi except tangent and cotangent, which has pi, right? So the original will be 2 pi, but I have to divide it by the number that multiplies x. This is the number that multiplies x, so that's why the period is pi. If you remember, we said when x gets changed into twice x, it's not this, but it's this. That's why the period changes from 2 pi to pi. Okay, now the phase shift cannot be determined before from these 2 terms, I pull out a 2. I'm not changing the problem or the function, but I have to pull out 2 out of that, not cosine, out of the parentheses that cosine is applied to. So this becomes this. Still, cosine is applied to the same quantity. But if I pull out a 2, what is left in parentheses?
X minus pi.
Exactly. This is what we call the phase shift. And it is to the right. Exactly.
Do you want us to say that?
I'm fine with this.
Okay.
I'm fine with this. Okay, let's look at 5.8. Yes? Say it again? No. No, I will not torture you with that.
Was there something from 5.6?
This is 5.5 and 5.6. I will not ask you anything about tangent, cotangent, secant, and cosecant. We did not work on those enough. Okay, on page 630, what to expect from here?
Are you gonna have us make like the core cosine, the function out of a graph? Like the core cosine 2x pi from the graph? There's questions in the book that we just.
Yeah, I would like to see them. Where are they?
Um,
Oh, it tells you that the transformations are A, B, C, D, F, G. Come up with a function.
Page 206.
206.
602.
602.
They teach you the graph and it says make the function out of there.
No, I did not put a problem like that, but let's do one. Where are they?
139.
Oh, I see. Oh, the graphs are given. The graphs are given.
Yeah.
Okay. So I did not put a problem like that, but let me just talk about it for 1 minute. So I'm copying y equals tangent x. I'm not looking at the graphs. I'm just copying those 4. Y equals tangent x plus pi, and then y equals negative tangent x, and then y equals negative tangent x minus pi over 2. Very good. Okay, perfect. I'm going to start with the easiest. This is the easiest. I hope you remember that the function has vertical asymptotes, and this is at negative pi over 2, and this is at pi over 2, and this is the graph. And we said, similar to x cubed, but remember x cubed does not have vertical asymptotes. X cubed looks like this, goes on forever, right? This is not limited. The tangent is between negative pi over 2 and pi over 2. So this is tangent x. Can anyone tell me how to graph this? What transformation is that on tangent x? So this is tangent. What am I doing now to tangent if I want to graph negative tangent? Where does this branch go? Where does this branch go? Okay, which one is 1, 2, 3, or 4? It is 4. It's still between negative pi over 2 and pi over 2, right? So it must be number 4. Good. So this is done. Now, this one. Where does this go? What is its phase shift? Yes. So then this vertical asymptote will move with the graph where? To negative pi. And this one will go here. So this graph will move here because it's a phase shift of pi over 2 to the left. Do we have a graph like that with vertical asymptotes at 0 and negative pi? They're shrewd. They're not showing us that part. In number 3, right? So it only shows one period between 0 and pi. It does not show between negative pi and 0. But it is number 3, right? Because what is between 0 and pi, it will be between 0 and negative pi. But they're not showing that portion of the graph. So it is number 3. Good. Now what about this one? So the initial graph is between negative pi over 2 and pi over 2. So this is the original graph. So now the phase shift is still to the left, but this time pi. So this moves pi. And this moves pi. So there is no change. So which one has no change whatsoever, actually? 3 was accounted for, 4 was accounted for, and the one that does not change, is it 1 or is it 2? Exactly. So this is number 1. Although we know which one will be number 2, let's analyze it. So first of all, I graph the base function, which is tangent x. Then I have to shift it, and I have to shift it pi over 2 in which direction? To the right. So then the new graph, so this is tangent x. The new graph shifts just pi over 2 to the right. It's this now. So this is tangent x minus pi over 2. But in addition to that, I have a minus in front. What do I do now to the orange graph? Flip it. So it's this graph. We didn't have enough time for this. So is it clear why number 2? What did I count number 2? But so x plus pi over 2, that is correct. Negative tangent, that's correct. Number 4 is very clear. This looks like number 3.
Yeah, it does. Because that's opposite.
Yes, this is like number 3. And number 2. Oh yeah, I'm sorry, that was my error. Sorry, I apologize. So this is number 3, and this is number 2. Because it's this. Right? That's number 2. This was number 2. We didn't have enough time to study the transformations on this function. Okay, good. So moving forward to 5.8. Okay. We looked at word problems here. We did a lot of word problems. Let's find another. Okay, let's look at 42. On page 631.